All right, yeah, welcome back. Now if you remember when we stopped last time, we were able to successfully import our data in two different formats. We imported using TPS. We also imported using text or what's called row/columns format. So these are the two common formats we have used so far to import data, and this is very important. And it's actually the common type of data import you will be having. If after you collected your data, it will be usually in TPS, but for sake of simplicity, you can convert to text or column format so that you'll be able to handle it appropriately. I will explain further what I mean by that as we continue in this training or in this class. Now, the next thing you want to do now after bringing your data is to perform what is called Procrustes Fit. Procrustes Fit is actually otherwise called GPA. It's called General Procrustes Analysis. All right. So it is the next step we perform. In MorphoJ usually uses a full Procrustes Fit, all right, and project data to the tangent space by orthogonal projection, right? For most applications, there is very little difference between the different methods for Procrustes fitting. Okay, we have a full versus partial Procrustes fit. There are little difference, but for data set with unusual large variation, the full Procrustes fit puts less weight on observations that are far from the average shape, and will therefore be somewhat more robust against the influence of outliers, right? So, there are several examples of Procrustes fit, actually, several examples, even in this particular MorphoJ we're talking about. We have three types, basically, which I will explain later. But when you bring your data, you can check your data against outliers. Okay, how do I mean that? For example, when you bring your data into MorphoJ, you can first, before you do Procrustes, you can first click on the find outlier here. By clicking on find outlier, let me cancel so that you can see what I did. I'm selecting the first one. They are both the same, okay, the same data, okay, no difference. So I'm just using the first one for now. So I click on this. I click on find outliers. Right. So here you want to see if the data is deviating from the normal variation. Maybe you can see their score here, and you can see that data can be excluded before you perform Procrustes fit. You can see the relative frequency line, Nobis distance here. You can see how it moves like this. If the shape, sometimes shape will be somehow abnormal, then it means that some data are deviating. Okay, so you can exclude those. You can exclude here before you proceed further. Okay, you can exclude those data from here. Okay, any points that is deviating, you can exclude them here. But there's no problem here. Everything is fine. You can see from here. You can flip. You can rotate. Okay, if I flip vertically, or I can rotate twice. So this is the shape of the face, right? So if I'm okay, I can just cancel, or if I adjust anything here, if I exclude or include anything here, I can just accept. So I'm not doing anything because it's okay. Okay, this is okay. So I can just cancel here. So now I can go and perform my Procrustes fit now. I click on preliminary Procrustes fit here, because this is called Procrustes fit. All right. We have three here, but the main one here is to align by principal axis. All right. That is the default, and that is very important, because others, the first one is talking about object symmetry, which if you continue further, you understand what that means later. I will use that to explain another concept of morphometry for us later. All right. So this one is aligned to using specific landmark. Maybe you have landmark you have already arranged. You want to select. If you are not generalizing the landmark now, you just want to pick some points, okay, between this and this, between from here to here. that is when this one is needed, which is very rare. All right, you have to align first to principal components as it, so that is uh, the best way to handle Procrustes Fit. All right. So when you do this now, if I click on, if I just, for this one is selected, which is default, which is very important, align to principal axis, then you click on perform Procrustes Fit here. When you click on it, to show, it give you this. So I can flip again, okay, to see. I can see so you bring it up. You can see. So this is my Procrustes Fit now. All right. So this is what you have. This is what they call general configuration now. Okay. Okay. This general configuration. All the shapes is aligned to a general configuration. All right. This is what is called mean configuration. Mean. This is mean. Okay. Or average configuration of the data set. So if any problem here is happening, you can certainly visualize it here before you proceed further. But if this one is okay, then it means that you have successfully performed your proof without any error. Sometimes it can give some error around here. You can just say error, red error, especially when you are doing what is called symmetry. It can give some error. That means your points are not properly aligning, so you have to do afresh. There's a problem with your landmarking or annotation, so you have to go back and do afresh. But now everything is fine, so this is why it gives you like this. You can see all the points in proper places and with the numbers alongside with them. So this is the called Procrustes as well, superposition actually in Morphometrics. So thank you so much for listening for today. I will continue from there the next class too. I want us to do step by step without rushing everything at once. Then you see. So we are going to continue from this step in the next class as we look at the next course of items. So thank you so much for listening. I'll see you in the next class.